All right, I'm back. I don't know what happened. Loom crashed on me. But here we are, part 2. So you've gone too far in trigonometry. 30 minutes was long enough. So here we go, part 2, get a little break. Hey, can you find the angle where the answer is root 3? So I'm just going to pick up where I left before. Tangent is y divided by x. So 1 divided by root 3 is not that answer. Root 2 divided by root 2 is not that answer. But root 3 divided by 1 is. This is what I'm looking for. So in radians, that answer is over 3. And then think what quadrant we must be in. So 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. That's the unit circle. It's these. So first of all, tangent is a positive root 3. So in quadrant number 1, it's positive. So that's pi over 3. Where else is tangent positive? And that's this quadrant, number 3. So the two answers are pi over 3 and 4 pi over 3. Let's look at part B. In part B, you have cosecant equaling -2, and find the angles where that would be true for. So again, I'm going to go back to these angles. 30 degrees, that's root 3 over 2, and 1/2. 45 is root 2 over 2 and root 2 over 2. And then 60 is the inverse of 30. So we go back. That's a foundation. Cosecant is the reciprocal of sine. That's just the y-coordinate. So if I look at these y-coordinates and do the reciprocal, which one gives you the answer, 2 or -2? So this is what we're looking for. The reciprocal of 1/2 is 2. It's negative because of the quadrant it's in. So our next step is, okay, I know this. So it's 30 degrees is over 6. So these are the angles in the quadrants. And I need to know, okay, so remember I went 1 over 6, 2 over 6, 3 over 6, 4 over 6. All those simplify with 6. The next is 5, then 7, 11. Those are the numerators that don't simplify with 6. Those are the numerators that keep 6 in the denominator, even and it's in lowest terms. So those are the angles in the quadrants. Now I just need to know, where is cosecant negative? Well, cosecant goes with sine, and sine is the y-coordinate. So the y-coordinate is negative down below. So the two answers are 7 pi over 6 and 11 pi over 6. That's it. All right, number 13. This is our last trigonometry question. I'm sure you're happy that's the case. I know it's not easy, and it's especially not easy if we didn't put in the work last year in trigonometry. And even if you did work at it, it still doesn't make it easier. So I get it, but it's not going to be easier by not working at it. So we're going to have to work at it together, all right? So secant squared subtract 4 equals 0. I want to solve that without using a calculator. So step 1 is I'm going to add 4 to the other side, and I'm going to square root. So if I square root this, the answer could be positive or -2. And when I solve it, again, I need to remember my quadrant. I'm just not going to rewrite it. Secant is the x-coordinate, and it's the reciprocal. Which of these will give you 2 or -2? For the x-coordinate, so we're looking at 60 degrees. So then I draw, and I realize, wait a second, it's positive and negative. So that means it's all angles from 0 to 2 pi. So if that's the case, if it's 60 degrees, then it's 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Notice how I skipped 3 over 3, because if you simplify it, it's no longer 3 in the denominator, and we have our answer. Number 14. We still have another question, right? 13. So 13, we have sine squared is equal to cosine squared. And we have to solve this. All right. If I square root both sides, I end up with that. And what I'm looking for is, where is sine theta equal to positive, or where is sine theta equal to negative? So which of these angles is x and y the same number or opposite signs? So it's at 45 degrees. And again, it's all solutions because it's positive and negative from 0 to 2 pi. So 45 degrees is over 4. That's 3 pi over 4. That's 5 pi over 4. That is 7 pi over 4. And you have your answers. That's it. No more trig for this assignment. Number 15. 14. That was 14. Number 15. In number 15, f at 0 equals 1. F at 1 does not exist. F at 2 equals 2. The derivative is negative when x is less than 1 and between 1 and 2. The next one the derivative is positive when x is greater than 2. And then it talks about the second derivative and so on. So let's just draw number lines to be able to understand this better. And then at the end of it, we're going to try to sketch it. So far, this is what I know about the graph so far. So what I know about the graph is I have a point at 0, 1, and at 2, 2. So I know that. And at 1, it's undefined. It's probably an asymptote there, or it could be a hole. Either one. I'll do that, an asymptote there where it's undefined. All right. Then it says the derivative is negative when it's less than 1. So here's 1. That just means it's decreasing. And then it's also negative from 1 to 2. But when it's greater than 2, it's positive. That's what it's saying. So there's the first derivative number line. And then the next one is the concavity part. So for the concavity part, it's just 1. So it's negative when it's less than 1. And it's positive when it's greater than 1. So just to be able to read it, understand concave down and concave up. So we have concave down. That's this side. So it's decreasing and concave down. And then on this side, it's concave up. Now, it's still concave down. So it's still decreasing from 1 to 2. We actually have a minimum at 2. So it's going to look something like this, where we have it decreasing and then increasing. We have concavity. So that's what the graph would look like. So decreasing, concave down, concave up with a turning point. Done. Number 16. In number 16, find the IROC. So f at x equals negative 2x plus ln x. And find the instantaneous rate of change. So that's the derivative. Let's do that first. So there's the derivative. And then find the derivative at 1. And then find the derivative at 2. And you have the answer. All right, so there it is. Just be able to finish that through. For for B, that's part A. Part B, find the average rate of change, AROC, of the same function from 1 to 2. So to do that, we take the y coordinates. So that's f at 2. Subtract f at 1, and then 2 take away 1. That's the formula for AROC. So we just found Do we find f at 2? So f at 2, plug 2 in. That's negative 4 plus ln 2. Subtract. Plug 1 in. That's negative 2 plus ln 1. And then simplify that. So when you divide by 1, it doesn't change anything. Negative 4 subtract negative 2. That's negative 4 plus 2, which is negative 2. Ln 1 is 0. So all we're left with is ln 2. And there's your answer. So it's negative 2 plus ln 2 is the answer if you simplify it. That's the A rock. Number 17, it says find the C value where the derivative is equal, where I rock equals A rock. So we have negative 2 plus ln 2, make it equal to the derivative, which is negative 2 plus 1 over x. So the negative 2's, they divide out. So ln 2 equals 1 over x. So if I solve for x, just do the reciprocal if you like, or multiply by x and then divide. It's 1 over ln 2. That would be the C value. Number 18. And that number is actually between 1 and 2, just so you know. It has to be. Find the average value. So the word average value means we're going to integrate the function. So we're going to integrate negative 2x and ln x, and we're going to integrate it from 1 to 2. And then divide by the difference in the bounds. So 2 subtract 1. That's divided by 1. So I just need to do the antiderivative. So negative 2x, the antiderivative would be negative 2x squared divided by 2. The antiderivative of ln x. Or would I need a calculator? I think I can't, because I can't. We don't have an antiderivative for ln x. So I'd actually have to put that in a calculator. So I got stuck at there. So I realized, wait, so we don't have a rule for the we have a rule for the derivative, but we don't have a rule for the antiderivative there. So I'm going to go menu calculus integrate. And I'm going from 1 to 2. And it's negative 2x plus ln x dx. Oops, there. So I don't need to go divided by 1. And I get negative 2.613. There we go. Oops, the calculator right there, negative 2.613. Number 19. Now it says without using a calculator. Find the maximum value of that. So to find it, we take the derivative equal to 0 and then the end values of it. So the derivative equal to 0, we did the derivative before. That's negative 2 plus 1 over x. If I solve that, then x equals 1/2. That would make it equal to 0. Know the domain restriction, which is 0 on, because a logarithm can't have a negative number inside. If I look at this and I plug into the derivative a number that's like 1/3, you can see the answer is positive, and then plug in a number past 1/2, like positive 1 or whatever. So it goes positive to negative. So that creates a maximum at 19. So the maximum value there would be at 1/2. So if I plug that in to find the maximum value, I'd have to go back into the function and then plug it in. So plug that in 1/2 back into the function. You have negative 2 times 1/2 plus ln 1/2. So just plug it back into the function, you know, our original function that we've been working with. Put 1/2 in for x. You could simplify that to negative 1 plus ln 1/2. That's the maximum value of the function. That's number 19. Number 20, we're still using the same function in number 20. So it says use an equation of a tangent line at x equals 1. So when x equals 1, the y coordinate at 1 plug 1 in for x. Remember, ln 1 equals 0, so that's negative 2. And then the derivative for the slope. So the derivative again was negative 2 plus 1 over x. So it's negative 2 plus 1 over x. Plug the x coordinate in. So it becomes negative 2 plus 1, which is negative 1. So the tangent line is negative 1, x minus 1 minus 2. And then use that line to approximate 0.9. So plug in 0.9 for x. That's 0.1. That's negative 0.1. A negative times a negative is positive 0.1. And then 0.1 take away 2. Think of money, and you get $1.90, right? Negative $1.90 or negative 1.9. $21. For question number 21, we're going to approximate the integration by using a trapezoidal rule. Wow. Okay. So 1 through 4, negative 2x plus ln x. This is what I'm here for, to help remind you. So the trapezoidal rule with 3 equal subdivisions. So I need to find the width. That's the subtract the limits divided by 3. So if I simplify it, the width is 1. So when I approximate it here, I'm going to start with the formula, which is 1/2 times the width, which is 1. And then I need to plug in the heights. So if I plug in 1, you end up with negative 2, because ln 1 is 0, plus, and now you double it. So the next number you're going to plug in is 2. The next number you're going to plug in is 3. And then the next number would be 4, but you don't double that one. And there it is. So 1/2 times 1. So the rule for the heights, the first one and the last one are singular, but the heights in the middle are doubled. And you just substitute in. So if the width is 1, that's how much you count by. So first you plug in 1, add 1, now you plug in 2, now you plug in 3, and so on. You can visualize it, from 1 to 4. The trapezoids have an equal width of 1. So you're using 1, 2, 3, 4 when you plug in and know the rule. All right, number 22. We're almost there. So for 22, this is called the fundamental rule of calculus, the sequel. So the derivative and the integration undo each other. So this is just a substitution question. So for number 22, can you substitute in? The derivative of t is 1, so I don't need the hook. When I plug in 1 and take the derivative, the answer is 0, so you have your answer. For number 23, again, this is the fundamental rule of calculus. From x squared to 5. This is not a trigonometry question. This is a substitution question. So first, we're going to substitute 5 in and take the derivative. So a derivative of any constant, including a trigonometry constant, is 0. Subtract, and now I plug in x squared. So it's sine 2x squared. And then the derivative of x squared is 2x. We need the hook of the limit in terms of that. And you have the answer. Last one. We got this. You ready? 24. Not a fundamental theorem of calculus question because we're only integrating. So we're integrating x times e to the x squared dx. So no derivative in front, no substitution question. We got to do the antiderivative. The derivative of x squared is 2x. That's the hook I need. So I need the fraction 1/2 in front. Now I can undo that hook. So it's 1/2 e to the x squared, because that's the rule for e. You just copy it. And then the bounds, or the limits, go from 0 to 1. We're going to plug in the upper limit first. So 1 squared, that's just 1/2 e. Subtract. Plug in 0. E to the 0 is 1, so it's just 1/2 e subtract a half. And you know what? We're done. Mr. G Math over and out. I'm proud of you. I know it wasn't an easy assignment. I know that to understand it, you're going to work. Sometimes you got to go over a question 2 times, like rewind and see it again. Sometimes you need to ask me a clarifying question. All of that. But I'm thankful that you're not giving up. You're fighting and doing the best you can. Mr. G Math over and out.